Evaluate the limit as x approaches negative infinity of this huge rational function. We got a polynomial divided by a polynomial, and we have to find the limit as it approaches negative infinity. So what we're going to do here is use this technique where we divide by the highest power in the denominator, in this case x to the fourth. In other words, multiply numerator and denominator by the reciprocal of the highest power. Now that's the same as dividing by the highest power. So in the numerator, what this is going to give us is, I multiply this by all three terms. So we get 2 times x, because the power goes down by 4. 3 times x to the fourth, that just becomes 3. And negative 31x, one of the x's will cancel out, but it'll be divided by x cubed. So we'll have 31 over x cubed. In the denominator, the x to the fourth will cancel. X squared will cancel, but another x squared will be in the denominator. And 12 will be 12 over x to the fourth. So again, this expression is equal to the original expression because we multiplied numerator and denominator by the same thing. And if we take the limit as x approaches negative infinity of the numerator and then divide it by the limit as x approaches negative infinity of the denominator, that will be our answer, right? The limit of a quotient is the same as the quotient of the limits. So in the numerator, if we plug in a very large negative number, so say negative 1,000,000 or something, 2 times x would be 2 times that large number. Again, very large in the negative direction. Plus 3, that doesn't really matter because that large number is so large, 3 doesn't even compare in size. And x cubed, that very large negative number cubed, will be an extremely large number. And so 31 over x cubed would just be basically 0. It'd be equivalent to 0. So in other words, in the numerator, as x approaches negative infinity, this is the only term that remains, and it just keeps getting larger and larger in the negative direction. And so we say the limit here is negative infinity. Whereas in the denominator, if I plug in a very large number for any of these, it'll be extremely large, and so both these terms will go to 0, and all I'm left with is 8. So we have negative infinity divided by 8, which we just say is negative infinity, and that's our answer.